Hello, in this video tutorial I will show you how to set up obstacles in Nav3D, and I'll tell you a little more about some of the features related to obstacles. First of all, in Nav3D obstacles can be game objects with a mesh assigned in mesh filter or with an attached Unity terrain component. I will show you how to deal with obstacles that have attached mesh filter component. To work with obstacles, the Nav3D obstacle component is used. It must be attached to the game object you want to make an obstacle. I have a scene with a cube that I want to make an obstacle. I also created Nav3D initializer object, which is needed to initialize all Nav3D systems when scene starts. In this tutorial, I will not use Nav3D agents to follow the path, but show how to use Nav3D path tester component to make sure that the path is correctly searched among obstacles. Let's attach the Nav3D obstacle component on the cube. And let's create Nav3D path tester object. Let's create 2 points between which the path will be searched and assign them to the targets field of the created Nav3D path tester. And let's see how everything will look in the play mode. To see the path and the result of obstacle processing, the gizmos visualization must be enabled. We can move the target points of the path and see how it is rebuilt. In the obstacle inspector, you can enable the display of the obstacle navigation graph nodes. You can visualize occupied OC3 cells, the free one, OC3 cells, and whole navigation graph, its nodes and edges. To have an obstacle processed and added to the Nav3D system, it can be created at any time during the game, or an existing obstacle game object can be enabled. Disabling or destroying the obstacle game object will remove the obstacle's navigation graph from the Nav3D system. Moreover, the Nav3D obstacle manager is also quite smart and keeps track of which existing paths were crossed when the obstacle was enabled or created. For crossed paths, it triggers an update. This is true for all paths currently registered by Nav3D, whether it's an agent path, a Nav3D path tester path, or a Nav3D path object you created yourself. Let's turn on our obstacle after the path has been found and see what happens. We can see how the path updated after obstacle was enabled. There is an interesting option that allows updating the obstacle graph dynamically if the values of the transform component have changed. Each update involves rebuilding the navigation graph so that the obstacle is first removed, then processed again, and added to the obstacle manager. This is the minimum update period. It is worth considering that processing the obstacle and construction of the navigation graph is a time and performance consuming operation, so it should not be used too often. Now let's see how it works. The obstacle processing system can group obstacles that are located close to each other. Each obstacle has its own bounds. It is drawn in white when the visualization of the graph nodes is turned on. If the bounds of two separate obstacles intersect at the time of processing, then a new bounds is derived from them, and a common navigation graph is built. The size of the bounds of each obstacles depends on the minimum bucket size of the navigation graph, which is set in the inspector of the Nav3D initializer component. Let's try to create obstacle close to first one and see how the navigation graph will be built for both obstacles. In fact, a more preferable and reliable way to create a grouped obstacle is to create an obstacle group with a Nav3DObstacle component attached only to the root object of the transform hierarchy. Let's remove the separate Nav3DObstacle components and create a root object for all obstacles onto which we'll attach one Nav3DObstacle component. There is the same result. This option in the Nav3D Obstacle Inspector means that all children in the transform hierarchy of the object will be used to create the navigation graph, and not just the object on which the Nav3D Obstacle component is attached. If for some reason we don't want any child object to be taken into account when constructing the navigation graph, then we can assign a special component to it and it will be ignored. Let's try it. In fact, obstacle processing takes a significant amount of time and affects performance. Still, building a navigation graph during play mode is only suitable for small obstacles. If the obstacle is large, then you should use the pre-baked navigation graph. So, on the start of play mode, the navigation graph will not be calculated, but will be loaded from a binary file. In general, loading from a binary file is always much faster than building a graph on the fly. So it is worth using it whenever possible. To do this, switch the processing type in the Nav3DObstacle inspector to load from binary. And then you need to create a Nav3DObstacle loader. And bake the obstacles. Here you can see the list of the obstacles that can be baked. Let the binary file be saved in the scene unclosing folder. Here it is. Now let's make sure the obstacle was loaded. Yes, everything is fine. There is also a nuance, which consists in the fact that obstacles loaded from a binary file cannot be disabled or updated in play mode. They should be perceived as permanent static obstacles. If you have any questions about working with obstacles, read the documentation on the site. Many questions are described in more detail there. You can also ask a question by mail or on the forum thread dedicated to Nav3D. Thanks for watching.